to part B. Okay, B part 1 says define the term standard enthalpy change of combustion butane to ore. Butane to ore. Okay, so standard enthalpy change of combustion. Hope you all remember combustion, right? It must be energy release or energy evolve. Okay, must be energy evolve. Okay, energy evolve when 1 mole of butane to ore is combusted in oxygen. Okay, under standard condition 298 Kelvin and 1 bar. Okay, so when you guys write down your definition, right, what's the important thing? Is you must ask yourself, is the energy released or absorbed? Okay, if it is not confirmed that it's either one, right, you can put energy change. But if things like combustion, right, you must know that is energy is released. Okay, if you put energy change, right, you will probably be penalized. Okay, you'll probably be penalized. And then the second thing you want to take note is you want to tell them 1 mole of what. Okay, because all the definition, all the enthalpies, right, you have to highlight and define is 1 mole of what. Like for neutralization, it is 1 mole of water form. Combustion is 1 mole of something burnt. Okay, so every time we have to define for them what is the 1 mole. Okay, what is the 1 mole? Standard condition, if let's say you cannot remember what standard condition, right, you can just put down standard condition. But if your school wants you to write down what exactly are those conditions, then you make sure that you remember these two lah. Okay, if they never specify you must list out, then you can just put standard condition. Okay, so that's for definition. For part 2, using the following data, calculate enthalpy change of combustion of butane to ore. Butane to ore. Okay, so maybe I'm just gonna erase this. Let me erase this. Erase this. Okay, so we're gonna use the given data, formation of carbon dioxide. Okay, formation of carbon dioxide pointing up, minus 394. So since there's 4 of them, right, you need to multiply by 4. Multiply by 4. And then we have formation of water, go up again. How many of them? 5. 5 times minus 286. Okay, then next formation of liquid, butane to ore, there's only 1 of it. So we'll just put minus 343. Okay, so by right, you're supposed to write down all the elements at the bottom lah. Okay, by right, but actually we don't need to draw a cycle. They didn't ask us to draw a cycle anyway. Okay, I'm just drawing a cycle to show you guys. Okay, so where are the arrows pointing and why we should be putting products minus reactants. Okay, so let's apply Hess's law. Clockwise, like this. Clockwise equals to anti-clockwise, like this. Okay, so if you want to go ahead and write it down, you should have so this one we'll call the enthalpy change of combustion. Okay, so enthalpy change of combustion plus minus 343 is equals to 4 times 394 plus 5 times 286. Okay, so guys, if you are here and you're looking at this equation, please do try to calculate out delta H of combustion, see whether you can get it, and type it in the chat. Okay, I'm just gonna wait like a minute or so. If there's anyone who wants to calculate. Oh, Sniper, well done, well done. You actually got the answer. Like that's like within what, 10 seconds? Super fast, yeah. Very good. Okay, I hope this is helping you. That is the correct value. Okay, this is the correct value. Minus 2663. Well done, well done.